Hello students, in this video you will learn what is a differential equation, what do we mean by degree of a differential equation and order of a differential equation, right? First of all, we'll define what a differential equation is. Suppose we have two variables x and y, and this y variable is not independent and it depends on x. It means that if I will change the value of x, the value of y will accordingly change, right? Then I'll call this x as an independent variable, right? And this y will be called as a dependent variable, right? Then this derivative of y with respect to x, you all know, you are familiar with this term. This is called differential coefficient of y with respect to x, right? And this differential equation is of order 1, of order 1. Similarly, I can have a differential coefficient of the dependent variable y with respect to the independent variable of order 2, and so on. I can have of order 3, of order 5, or of order 6, and so on, right? Now, an equation which contains x, y, and the differential coefficients of the dependent variable y with respect to x is called a differential equation. So, an equation which contains an independent variable x, dependent variable y, and differential coefficients is called a differential equation, right? So this differential here the differential coefficients can be of any order. They can be of order 1, of order 2, of order 3, and so on, right? So for example dy by dx is equal to 2xy. This is a differential equation. Here x is the independent variable, y is the dependent variable, and dy by dx is a differential coefficient of order 1, right? d2y by dx square is equal to 4. This is a differential equation. It does not contain x and y, but that is not a problem. It is not, required that x and y should be there, right? Only requirement is at least one differential coefficient should be there. Otherwise, it is not a differential equation, right? It may be independent of x and y. Like x and y may not, appear explicitly in the differential equation. dy by dx, next example is dy by dx is equal to sin x plus cos x. There are so many examples of differential equations, and there are so many real life situations where we need to solve these differential equations. We'll eventually learn how to solve these differential equations. First we'll learn some basics. So a differential equation is an equation which contains an independent variable x, an a dependent variable y, and the differential coefficients, and these differential coefficients can be of any order like 1, 2, 3, and so on, right? Next thing I'm going to define is what do we mean by order of a differential equation. Now we will define order of a differential equation. Right. Order is the order of a differential equation is the order of highest order differential coefficient occurring in the differential equation. Okay, first we will write down order of a differential equation is the order of highest order differential coefficient occurring in the differential equation. Right? For example, see this differential equation. d2y upon dx square plus 3 dy by dx plus 2y is equal to e raised to power x. This is the differential equation. Here x is the independent variable, y is the dependent variable. This is the differential coefficient of order 1. This is the differential coefficient of order 2. So here the order of the highest order differential coefficient is 2. This is the highest order differential coefficient and its order is 2. So the order of this differential equation is 2. Right? Now consider this differential equation. Just a minute. Now consider this differential equation. d cube y upon dx cube plus 6 dy by dx raised to power 5 plus 7y is equal to 2. Can you tell me what is the order? Here x is independent variable, y is dependent variable. This is the dependent differential coefficient of order 1 and this is the differential coefficient of order 3, and this is the highest order differential coefficient occurring in this differential equation. So the order of differential equation is 3. It is not 5. Okay, 5 has nothing to do with the order of this differential equation. So the order of this differential equation is 3. So it should be noted that order of a differential equation is always a positive integer. Why? Because we can't have a half order derivative of y with respect to x. It is either a first order derivative or second order or third order and so on. Right? Next thing we are going to define is, what do we mean by degree of a differential equation? This is very important. Right. Degree of a differential equation is the degree of highest order differential coefficient when this is important, when the equation is made free from fractions and radicals. What does that mean? It means that before deciding what the degree of a differential equation is, we need to make the differential equation free from fractions and radicals. Right? Okay, first we'll start with simple thing. dy by dx plus y is equal to x square. This is a differential equation. Here x is the independent variable, y is dependent variable, and this is the differential coefficient of order 1, and this is the highest order differential coefficient of occurring in this differential equation. And what is the power of this differential coefficient? It is 1. So degree of this differential equation is 1, right? Now see this thing, d2y by dx square raised to power 4 plus dy by dx is equal to 2. This is the differential equation. Here, what is the order of the highest order derivative? That is 2. So order of this differential equation is 2. And what is degree? Degree is the power of the highest order derivative, that is 4. So degree in this case is 4. Right? Now, see this thing. Consider this differential equation. Y is equal to x dy by dx plus 1 plus dy by dx raised to power 2, and this is cube root. So what is the degree of this differential equation? What is the order of this differential equation? The highest order differential coefficient is of order 1, this, right? So order is clearly 2, but we can't decide the degree unless we make our differential equation free from this. This is, what is this? This is radical. This is 1 plus dy by dx square raised to power 1 by 3. So I need to make, I need to get rid of this radical, this 1 by 3. So for that, what I will do, I will take this y minus x dy by dx is equal to cube root of 1 plus dy by dx raised to power 2. Now I'll take power 3 on both sides. I'll get this thing. Raised to power 3 is equal to 1 plus dy by dx raised to power 2. So now clearly the highest order derivative, which is dy by dx, has a power 3. So the degree of this differential equation is 3. So all you have to do is, you have to make your differential equation free from radicals and fractions before making your differential equation, before deciding the degree of the differential equation, right? Next is linear and non-linear differential equations. What is a linear differential equation and what is a non-linear differential equation? Okay. If I can write my differential equation, if I can write my differential equation in the following form. Which form? This is this one. That some coefficient times nth derivative plus some coefficient times n minus 1th derivative plus some coefficient times n minus 2th derivative, and so on. This goes up, and some coefficient times y is equal to q, where all pi's and q and all pi's, p0, p1, p2, pn, these are either constants, or functions of independent variable x. Y can't be, there inside these p1, p2, p3 and pn. This is the first thing. This is the thing. If I can write my differential equation in this form, then I say that the given differential equation is a linear differential equation. Right? So it means that, see this differential equation, x dy by dx plus y is equal to 5. Is this linear differential equation? Of course, this is my first order derivative, right? And the coefficient is a function of x only. Here y, its coefficient is 1, which is constant, and q is constant. So this is a differential equation, which is a linear differential equation, right? Now see this differential equation, dy by dx square plus y is equal to 5. Is this a linear differential equation? No. Why not? Because I can't have this thing. I have dy by dx. I have here dy by dx square. I can't have this thing for my differential equation to be linear, right? So this is a non-linear differential equation. A differential equation which is not a linear differential equation is a non-linear differential equation. For example, see this differential equation, sin x into dy by dx plus y is equal to x plus e raised to power x. Is this a linear differential equation? Yes, because here this is my coefficient, which is a function of x only. Here the coefficient is 1, right? And here q is a function of x only. So this is a linear differential equation, right? So what are the things which will make a differential equation non-linear? What are the things which will make a differential equation non-linear? The first thing is, if a differential coefficient right, has a power more than 1. For example, dy by dx square plus y is equal to x. This is a non-linear differential equation, right? Second is, if the dependent variable has power more than 1. For example, dy by dx plus, right, let me write d2 y by dx square plus y square is equal to x. This is not a differential equation because I have dependent variable y and it is, y square is there in the differential equation. So this is not a linear differential equation, but powers of x can be there, independent variable. For example, consider this differential equation. This is a linear differential equation and this is a non-linear differential equation, right? This is the first point which will make a differential equation non-linear. This is the second point which will make a differential equation non-linear, right? The third point is, there is a term in the differential equation which is product of independent variable product of dependent variable y and the differential coefficient. For example, I'll show you. If I have this differential equation, x square plus 1 into d2y by dx square plus xy dy by dx plus xy is equal to 5. See, this term does not have any problem, right? Because here the coefficient is a function of x only, right? But this term here we have a product of dependent variable y and the differential coefficient. So this is a non-linear differential equation. Okay, so this was about the degree and order of a differential equation and what a differential equation is. In the next video we'll learn how to form differential equations and how to solve differential equation. Thank you.